Yep.
So 2 KCl plus 3O2.
Perfect. So now, can I tell us on the assessment, I wouldn't give us a reaction like this and expect us without a little reminder of what do we produce when we decompose a metal chlorate. So Max, bravo, sir, bravo. So if this came on our test, I would say, remember, a metal chlorate when decomposed produces a metal chloride and oxygen. Yeah, so we're not in that chemical reaction chapter. So if I feel like we need just a little reminder, I'll give it to us. Perfect. Okay, are you at STP?
Yeah, I think I realized.
Wait, pause. Are you at STP conditions for number 4?
Oh, no.
No. Okay, so then immediately your brain has to say, okay, so I know I'm going to have to do 2 steps. One of the steps will be stoichiometry. So the question is, can I do the Stoich first and then the gas law, or the gas law first and then the Stoich? So what?
I think you have to do the Stoich first.
How do you know?
Because KClO3 is a solid.
So, you know, sometimes our brains like make different connections to remember. So how about if we are starting with solid, we do the stoichiometry first. I don't know if that kind of helps. Of course, I want us to just like think and not to memorize things. But so if remember, stoichiometry is based on mole relationships, So if you have grams and you know your formula, you get right to moles. Now, remember, you make a choice. I chose to get moles of gas and then use PV equals nRT. So Max, you're good? You don't?
I realized like I put the solid CIP gas law.
Yeah, so do you see? Yeah, so we have to be asking ourselves that question. Yeah. What else? Yes.
For number 4, why did you put out the 7.7
Did you employ the ideal gas law? Okay. If we use the ideal gas law, the curveball for that is we must accommodate the units on the gas law constant. So pressure has to be in atmospheres. Temperature has to be in Kelvin, volume has to be in liters. Okay. With this, get better with practice. So we're going to practice, and I wanted to just make it a little bit of a different kind of approach to the practice, but I definitely want to just any other concerns. Yes. Yes. All right. So what we have to be on guard for, and this is the second time that we're seeing a reaction of a very reactive metal. So number 5, alkali metal with water gives a metal hydroxide. If it's not alkali or alkaline earth, it's metal oxide. So remember that. So that we need first, right? Balanced equation. We are starting in terms of volume of gas, but I'm an STP. So I can get right into my stoichiometry. I can use 22.414 whenever we need it. So starting with milliliters of hydrogen, I know I need moles, I need moles, I need moles. This is gas. As long as I'm at STP, I can use 22.414 liters. That'll get me to moles, then mole ratio, then there. So just what else can I address?
Yeah, it was just my equation.
Yeah, that's what I find with that one, that it's usually shoot, that we forgot to balance, or we made lithium oxide instead of lithium hydroxide. Yes, sir.
I don't know if I did it wrong, but I got the wrong equation. Still like right answer.
Okay. So what it Okay, because the problem is just involving hydrogen, which I know that you know that's diatomic, and lithium. If this was an improper, yeah, then it just so happened that what I gave and asked for, if these were incorrect, also, if you had that incorrect, maybe it just so happened that you had those coefficients. So I know you're not really asking this, but you would have lost points for not having this correct, but not, does that make sense? So it worked in your favor. You made Li2O. Yeah. Wait, but you still need two. Oh, yeah. Yeah, you're exactly correct. And so it just so happened, you see, but what if I would have asked for this lithium hydroxide? Yeah. Okay. So just remember, very reactive metal hydroxide. Yeah. Thank you, Elena, for straightening us out there. No, did that address what you needed? And Abby, that address, and Max, you're all good.
Yeah.
Okay, what else? All right. We're incredible problem solvers. So this is what we are going to do before we get back our assessment gap from the last chapter. And I am really thinking that, this might take us 15 minutes, maybe 15 minutes. So just to make things a little different, you're welcome. I'm encouraging us to form groups of 2 or 3. So you can choose who you want to work with and where you want to work. So if you want to pull your desks together or go to a lab bench. So if I could ask you to read the directions I have for us. Is it understood what I'm asking of us? Okay, so 15 minutes, you're really working together and deciding together, are you good to go? So a little different. Usually I give us the correct answer, but now you are confident with your answer. You're answering it as a team. And then if there's a disagreement, just call me over. Okay, I think this will take about 15 minutes. Any questions on our directions? Okay, go, excellent problem solvers. All right, page 15. Could I ask us for Monday? For Monday, can we please answer number 1? And you're applying molar volume. So that means 22.414 liter per mole, not Ideal gas law. And number 2, 1 and 2. But then use the Ideal gas law, no molar volume, please. 4, we'll do 6, and we will do 7. And let's just do 1 Stoich. Leah, you choose. 9 or 11.
11.
All right, we'll do 11. So 5 problems for Monday. I will check for points. Okay, I believe it's self-explanatory what I did for our multiple choice. Yes. Please turn in